This section we're going to talk about complex numbers, but before we do so, recall if I gave you square root of 4, you would say that's equal to 2. However, if I gave you square root of negative 4, then there was no real number multiplied by itself to give you a negative 4, so you would either say undefined or not real would be our answer. Now we define the imaginary I, which is I is equal to the square root of negative 1. So when we define I to be the square root of negative 1, we can now look at square root of negative 4 and say, well, we can write that as 4 times negative 1, and then that'll give me square root of 4 square root of negative 1 split, and this is going to pop out at 2, and this is going to pop out an I with this new definition of I equaling square root of negative 1. So now we're able to say that square root of a negative number actually gets evaluated to this new idea, this new concept that's a number in terms of square root of negative 1, which is really defined to be I. So this leads us to the complex number system, which basically says that a complex number has form A plus bi. The I could be at the end or at the beginning, where the A is known as the real part of the complex number, and the B is known as the imaginary part of the complex number. Now if we think of numbers in general, basically we have the complex numbers like being the god of all numbers, and then inside the complex numbers is really the real numbers that we've been dealing with all along. So the real numbers are inside the complex number system. So let's look at an example. Is this a complex number? Having this in mind, what we just talked about, a plus bi being the standard form of a complex number, and the real numbers being contained inside the complex numbers. Well, this clearly fits this form, so this would be a yes, with real part 5 and imaginary part, let's spell imaginary correctly, shall we? Imaginary part 6. Is this a complex number? Well, that's a real number, but if we can imagine maybe like a plus 0i next to it, then yeah, sure, that could also be a complex number. We can just say yes, all real numbers are complex numbers. The real part here is 5 and the imaginary part is 0 because there's a 0i that I created with it. Now part C, is this a complex number? Well, if it has an I, obviously automatically it is a complex number, but you can also kind of think of this as there's maybe a 0 plus something with it, so that I can also say that the real part is 0 and then the imaginary part is 6. This is a purely imaginary number. Real part is 0. This is a purely real number which is inside the complex number system, so technically it's called a complex number as well, with an imaginary part of 0, and this can clearly be seen that it's a complex number. It has a real part of 5 and an imaginary part of 6. Now let's simplify some of these, just like we used to simplify radicals. Again, this one, you can think of it as 9 times negative 1, and then split it, so it produces a 3 and an I for the negative 1, so this is equal to just 3i. We could do the same thing here. We could say that's 18 times negative 1, so 18 we can deal with separately and the negative 1 separately as well. And then we can say, well, 18, we can think of it as 9 times 2, and that'll be 9 and a 2, which will pop out a 3 and a square root of 2. And remember, this also pops out an I, so I can think of this as just 3 and then square root of 2. And I can put the I far away, or sometimes you'll see the I in the front. sometimes you will see I right in the middle of these two. So all of these are okay, just make sure the I is far away and it's not under the radical. So essentially anytime you have a negative under a radical, an I is going to pop out. Now in this one, I have 5 times negative 1, which I can split as a square root of 5, square root of negative 1. There's nothing I can do here, but this one does pop out an I, so I just have square root of 5 times I basically, or I times square root of 5. Both of them are okay. Let's add and subtract complex numbers. Well, adding and subtracting complex numbers is basically like combining like terms. So when I look at this one, I have 3 plus 2i plus 5 minus 9i. So I'm going to look at the real parts together, which are going to be 3 and 5. And I'm going to also look at the imaginary parts together, which are going to be 2i and minus 9. So that's going to ultimately give me 8 minus 7i. So all I do is I combine the real parts and I combine the imaginary parts. Notice in this one, however, there's going to be a negative that's going to need to be distributed into that complex number. So we end up with 3 plus 2i minus 6 plus I. And once I do that, I combine the real parts together and then the imaginary parts together. So that's going to ultimately give me 3 minus 6 is negative 3. 2i and 1i is going to give me 3i. So adding and subtracting them is just like combining like terms.